I am Diksha Silswal from AIMS Rishikesh. Today I am moderating the session. It is 7th day of online SPSS series season 2. So without wasting a time, I would like to invite Dr. Ashok Kumar sir for further session. Over to you, sir.
Thank you, ma'am. So good evening, all the participants. Today is seventh day, and I'm sharing my screen. My screen is visible, ma'am.
Yes, sir.
Okay, thank you. So on 7th day, we have hands-on on how to give coding and decoding to quantitative variable. We have done for qualitative or categorical variable. But if we want to categorize the quantitative variable like age, systolic BP, BMI, HB, quality of life score, any. Okay, like age is exact age, and we can make category of this age variable. For example, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. So how to do this? We will discuss. When we talk about BMI, we have exact BMI, but we want to categorize according to ACR or WHO category. So how to do this? We will have demo on this, and after that we will have discussion on binary logistic regression to calculate odds ratio, unadjusted odds and adjusted odds ratio, AOR, that is a adjusted odds ratio. And for hazards ratio, we will have Cox regression hazard proportional model in SPSS function. So last day, we have discussed about simple linear regression and multiple linear regression. And in multiple linear regression, there is only one quantitative dependent variable. And I have given demo on dependent quantitative variable, that is HB baseline, HB at baseline. And there are multiple independent variables. They may be quantitative or qualitative or categorical. And in that demo, we have included age, BMI, and gender. BMI and age are quantitative variable, and gender is a qualitative or categorical variable. Okay. And the results were in the form of beta coefficient and p-value, and we make a equation line. Okay, and we predict using that equation line about HB of that years patient and male patient, and BMI is mean BMI, something like that. We assume that mean BMI of our data is this, and we calculate HB of that participant. Okay. So now today is multiple linear regression versus binary logistic regression. So when we talk about independent variable and dependent variable or outcome variable. So every time when we open this slide, there are two variable, independent variable, dependent variable. Dependent variable is outcome variable, okay? So independent variable in case of multiple linear regression, it is a quantitative type, okay? Independent variable in case of multiple linear regression, it may be quantitative of type or qualitative or categorical type. Quantitative means age or BMI, or qualitative or category means like gender. Okay. And for binary logistic regression, same thing. Okay, same thing, which we like quantitative or qualitative or categorical. So whatever. It may be quantitative or it may be categorical. Okay. But what is difference? Difference is in dependent or outcome variable. Okay, so in case of multiple linear regression, the dependent variable is a quantitative type of, only quantitative type of, only single, okay, quantitative type of. For example, HB, creatinine level, hemoglobin, weight, systolic BP, okay. But in case of binary logistic regression, it is a binary outcome. It is a categorical outcome, and there are the category are binary or dichotomous, not more than two. Okay. If it is more than two, it is called a multinomial logistic regression. Multinomial. But when outcome is binary, dependent variable is only binary, then we use binary logistic regression. For example, death or no death, you can see here, disease present or absent, result pass, fail, complication yes, no, okay, etc. If there is more than two categorical outcome, for example, none, mild, moderate, severe, then we have to apply multinomial regression. You have to remember this. So outcome or result in multiple linear regression, it gives beta coefficient and p-value. But in case of binary logistic regression, it gives in the form of odds ratio and it's 95% interval and p-value. Okay. So what is difference between binary logistic regression and Cox regression proportional hazards model? So please be attentive for this. So in case of binary logistic regression, independent variable is quantitative or categorical type. It may be 1, it may be 2, it may be 3, it may be 4, 5, 6, whatever. And for Cox regression model, same thing. Okay, it may be quantitative, it may be categorical, or it may be qualitative. It may be 1, 2, 3, 4, etc. And in case of dependent variable or outcome variable, for binary logistic regression and for Cox regression model, same. You can see there is a same. Okay. But when we talk about Cox regression model, so in Cox regression model, there is a time of event is also included. Time of event. Okay. For example, the outcome is binary outcome is a death or no death. So time of death we have to include. Okay. So time of death we have to include. Time of complication we have to include. So in Cox regression model, we have to include time of event. But in binary logistic regression, there is no time of event. Okay. So output as we have already discussed about in binary logistic regression, it is odds ratio, 95% confidence interval and p-value. And whereas in Cox regression model, it is hazards ratio and it's 95% confidence interval and p-value. 95% confidence interval of hazards ratio and its p-value. So this is main difference. Binary logistic regression and Cox regression model. In Cox regression model, there is a time of event included. But in binary logistic regression, the time of event is not included in the calculation. So what is difference? So we can say that Cox regression is equal to binary logistic regression plus time of event or outcome occurrence. So what is Cox regression? It is a binary logistic regression plus along with the time of event or outcome occurrence. So in binary logistic regression, the outcome is odds ratio, whereas in Cox regression model, outcome is a hazards ratio. Okay. Now in Cox regression model, there is one more thing, that is a censoring or sensor. So what is censoring? So sensor, we are observing the occurrence of outcome like occurrence of death at 3 months of follow-up in a follow-up study or occurrence of complication at 3 month follow-up in a follow-up study. Okay. And occurrence of any event of interest, any event of interest at 3 months, or it may be at 6 months, or it may be at 1 year, whatever. This subject, so what is censoring? the subject who did not develop that event of interest, the subject who did not develop the event, okay, until 3 months until completion of the follow-up. So it is censor, or left the study due to any reason, left the study in between due to any reason, they are considered or treated as a censor in Cox regression model. So you have to remember this. So where we use this censor, I will tell you, okay? The subjects who did not develop the event, or the left who did not develop the event till last follow-up day, or left or lost to follow-up due to any reason, they are considered or treated as censor in Cox regression model. Okay. So you can see in this picture, in this graph, you can see this is subject A, B, C, D. Okay, and this is months of follow-up. You can see here, this is a start of study. For this, we have started this study. Okay, one study from here. Okay, then what we see, it is cross is failure and zero is censor. What do you mean by failure? So failure is event of interest like death. Okay, here failure means event of interest like death, complication, or any event of interest. Okay, so this D patient or subject developed this event. It is cross at 4 months. Okay, at 4 months. So first thing, because this D participant developed this event, so it is not censored. Okay, it is not censored. Okay, and the time of occurrence of event is 4 months. You can see here. Okay, now what about C? C completed 1 year of follow, because this is 1 year of study. Okay, we want to see the development of mortality among cancer patients up to 1 year of follow-up. Okay, so this C subject, okay, start from here, he or she was enrolled in the study, and then follow up, and at the 12th month or last day of the follow up, he or she did not develop any event, without event, so it is called a censor. Now B subject started from here. Okay, started from here, because some participants enrolled early, and some participant enrolled later. So this participant enrolled here, and he or she was followed up to 2 to 10. It means it is 8 months follow-up, and in 8 months he developed this event. Cross marks means in development of the event or failure or death. So it is not censored. So B is not censored, D is not censored, but C is censored. Okay, and what about A? A is enrolled here. Okay, and then they, after 2 months of follow-up, there is lost to follow-up. Okay, there is a lost to follow-up. Okay, so we don't know whether he or she developed or not developed event of interest or not. Okay, whether he or she died or not, we don't know, because he is purely lost to follow up. So at 6 months, or like duration of follow up is 4 to 6. It means 2 months for A. Okay, because he or she is enrolled at here to 4 months, and then there is a loss to follow up at 6 months. So 2 month loss to follow up, it is a censored. So in Cox regression, censoring is very important. We have to give like censor is 0 and non-censor is 1 in coding. So this is loss to follow up and drop out at 2 month follow up, you can see here. Okay, so here D is not censored because he or she developed like event of interest. B also not censored, but C and A, C completed follow-up but did not develop event of interest or did not die, so it is also censored. And A is like he did not completed follow-up up to 12 month and developed and lost to follow-up. So we don't know whether he or she developed or die or not. We don't know. So it is censored. Now, what is odds ratio? So this is a 2 by 2 table. You can see here 2 by 2, very famous table. So dependent variable, you can see here lung cancer or any event of interest like death, complication, etc. And independent variable is smoking, exposure to independent variable. So what is our independent variable? Smoker, that is exposure to independent variable. And non-smoker, that is not exposure to independent variable. Please remember this. Here smoker, it means exposure to independent variable. And this independent variable, it is not only smoker, like smoking. We can take any example. Okay, for example, hypertension and non-hypertension. For example, diabetes and non-diabetic. So diabetes is your exposure to independent variable, and non-diabetes means not exposure to independent variable. Here lung cancer, this is lung cancer and this is lung cancer absent. So there are, we can see here, there are total 200 participants, subjects over there. You can see here grand total. So smokers or exposure to independent variable, out of 100, you can see there are 100 smokers and there are 100 non-smokers. So out of 100 smokers, 70 developed lung cancer, whereas 30 did not develop lung cancer after 1 year or 5 years, whatever. And in among non-smokers, out of 100, only 25 developed lung cancer and 75 did not develop lung cancer. Okay. So what is odds ratio? So we have to, these are, it may be complicated, but please understand one by one. Okay. So odds ratio, OR, or ratio of odds. So what is odds? We have to see this. Odds of having outcome of interest. So here outcome of interest is lung cancer in exposure, that is smokers. We can say it is a smoker or diabetes mellitus here, and lung cancer or any other disease. Okay, any other event. Okay, divided by, this is divided by odds of having outcome of interest, that is lung cancer or any disease, in non-exposure. That means non-smokers or non-diabetes or non-hypertensive. When we talk about hypertensive here, in exposure group, there is a hypertensive. We can see there is a CAD, okay, coronary artery disease. Okay. And when we talk about here non-hypertensive in non-exposure, that is a non, okay, we can take here as a CAD in outcome of interest. We can take any example. So what is odds? Odds ratio, odds of having outcome of interest or disease like lung cancer in exposure, okay, in risk factor group, okay, in risk factor group, that is a smokers. Or odds of having outcome of interest lung cancer in non-exposure, that is a non-risk factor patients or like or non-exposure non-smokers. So what is odds in odds ratio now? Any idea? So that is odds in bhav in Hindi or bet in English. Okay. Yes. Bhav in Hindi. Okay. And bet in English. We can say here. And when we like see newspaper and there is like IPL and World Cup of cricket, so there is a bhav 1 by 2, the winning chance. This is a chance, winning chance. Okay, winning bhav, odds of win, odds of win India. Okay, So like 2/7, 2/5, or 2/10, something like that. That is a odds. So odds of having, so what in odds ratio, we have divided odds of having outcome of interest in exposure and divided by odds of having outcome of interest in non-exposure. So what is odds of having outcome of interest lung cancer in exposure, that is a smoker. So what is probability of having outcome of interest in exposure divided by probability of having outcome of non-interest in exposure. So here outcome of interest, what is outcome of interest? Lung cancer. In exposure means smokers, divided by probability of having outcome of non-interest, outcome of non-interest. This it means no lung cancer in exposure. Exposure means smokers. So this is calculation. We can see here. What do you mean by probability? So we have to go in last slide. So this is probability of we can see outcome of interest in smokers in exposure. So what is probability? This is total and this is 70. So we have to divide it by 70 by 100. Okay. So this is a probability of outcome of interest in smokers. That is 70 by 100. And divided by probability of non-outcome of interest in exposure. So exposure is here smokers and non-interest outcome is no lung cancer. So it is 30 by 700. 30 by 100. This is a probability. So this is 70 by 100 divided by 30 by 100. And when we calculate here 100 and 100, it will be cut. So it is 70 by 30. And where is the n is equal to A divided by B. So what is A and B? You can see here A is cell first here and B is cell second. Okay. So it is A divided by B. Simple. So it is odds. Okay. You can say it is odds and odds of having outcome of interest in exposure group. Now, similar odds of having outcome of interest lung cancer in non-exposure. We have calculated for exposure. Now we have to calculate it for, calculate for non-exposures group. That is a non-smoker. So same thing, probability of having outcome of interest in non-exposure. So where is non-exposure? This is non-exposure. This is a non-smoker. So probability of having outcome of interest, that is a lung cancer. So what is probability? This is 25 divided by 100. So it is a formula to calculate probability. 25 divided by this 100, okay? Not this 100, this 100. Okay, to 25 divided by 100. And what about divided by probability of having outcome of non-interest in non-exposure. So non-interest outcome is 75. That is not lung cancer. That is our non-interest outcome in non-smoker. So it is 75 divided by 100. So this is probability of having outcome of non-interest in non-exposure. So when we calculate it, 25 divided by 100 and 75 divided by 100. So 100 and 100, it will be cut. Then it is 25 divided by 75. So it is C divided by D. And what is C and what is D? We can see here what is C and what is D. So this is C. You can see here, this is C, cell third, and this is cell fourth. This is D. So this is, you can see here, odds of having interest, odds of having outcome of interest in exposure is A divided by B. Whatever value in A and B, we have to just divide A divided B. Okay. And again, odds of having outcome of interest, that is lung cancer in non-exposure, that is non-smoker group. So this is C divided B. So whatever value in C and D cell, we have to divide. So what is odds ratio? We have to divide this odds, okay, this odds by this odds. So odds of having outcome of interest in exposure divided by odds of having outcome of interest in non-exposure, we have to just divide. So it is A divided by B, then divided by C divided by B. Okay, so D is fourth term, so it will go up and it will come like A multiplied by D divided by B multiplied by C. So you can see here. So this is, you can see here. So odds ratio, or like ratio of odds of having outcome of interest lung cancer in exposure or smoker group. Okay, divided by odds of having outcome of interest lung cancer in non-exposure group. So it is 70 divided by 30. This is a odds of having outcome of interest in exposure, and 25 divided by 75, that is odds of having outcome of interest in a non-exposure. So this is 75, it is a fourth term, okay, fourth value. So it will go up. So it is 70 multiplied by 75. It is a mathematical property. And this is divided by 30 multiplied by 25, you can see. So it is, when we like calculate it, it is come 7 divided by 1, it is equal to 7. So it's odds ratio of 7. So what do you mean by it? Odds ratio of 7. So interpretation of finding. So we can say, or we can interpret it as odds of having lung cancer in smoker is 7 times. Okay, 7 times more. We can say more. Otherwise, it goes 7 times compared to odds of having lung cancer in a non-smoker. So it is OR is 7.0, and this is 95% confidence interval. Like I just give example, we will calculate. Okay, so and p value it's coming, we will also calculate this. So it is, we have to like interpret our finding according to this. This is OR, odds ratio is equal to 7.0. Then 95% confidence interval, CI, that is a confidence interval. This is lower bound 2.572. This is upper bound 9.34. And this is p value 0.001. Okay. So this is like interpretation of finding of this odds ratio. Odds of having lung cancer in smoker is 7 times. Okay. Compared to odds of having lung cancer in non-smoker. So smoking is very dangerous, and it like may cause lung cancer because it's a 7 times more compared to non-smokers. Okay, so if non-smoker have odds 1, so like smokers for lung cancer, so smokers have odds of 7 times. Okay, 7 for lung cancer. So this is the interpretation of odds ratio. So this is, we can say in other sense, A divided by B and divided by C divided by D. So it is like we have to like this is like mathematical properties. So D will go up, A multiplied by D divided by B multiplied by C. It is AD upon BC. So if you want to calculate this odds ratio, what you have to do? You have to multiply AD divided by BC. Simple. AD divided by BC. So it will come odds ratio. It will very simple. Okay. So calculate odds ratio for this. So what we have? We have bed sore developed at 3 months after recruitment. Our independent variable is intervention group and control group. Okay. So it is our outcome variable bed sore development. So what is this? Is bed sore development? Yes, and this is no. And this is our exposure, that is the intervention group is our exposure. Okay, and outcome of interest is bed sore development. So what we have to do for odds ratio? We have to multiply multiply by D, A multiply by D, 11 multiply by 33 divided by B multiply by C, 39 multiply by 17. Then we can get odds ratio. It is very easy. So intervention group, odds of having bed sore development at 3 months is only 0.55. It means less than 1 compared to control group. Okay, compared to control group or non-exposure group. So it is 0.55. It means in intervention group, there is a less risk of development of the bed sore at 3 months, we can say. So interpretation of finding, odds of having bed sore in intervention group is 0.55 times compared to odds of having bed sore in control group, that is OR 0.55. We have to give also 95% confidence interval according to this, and p value 0.01. It is statistically significant. So in control group, if odds of having bed sore is 1, that in intervention group it is 0.55. It means it is lesser compared to control group. So in this case, odds ratio or hazards ratio null value is 1. You have to remember, null value is 1. So in control group, in non-exposure, it is always 1. Okay. So if you got odds ratio less than 1, like in this condition, we got odds ratio 0.55. So how can we interpret? Okay. So then you have to follow 2 steps. So step 1, subtract the odds ratio from 1. So okay, so subtract that odds ratio from 1, then multiply the result of step 1 by 100. So you can see, so have a look at our result of bed sore story. Odds ratio is 0.55. So it is less than 1. Okay. So first step, we have to subtract this odds ratio 1 from 1. So 1 minus 0.55, it is coming 0.45. Then in step 2, multiply this value 0.45 multiply by 100. It is 45% less development of bed sore in intervention group compared to control group. It is very big achievement, we can see. So interpretation of finding, odds of having bed sore in intervention group is 45% lesser compared to odds of having bed sore in control group. So in control group, it is 100%. So in intervention group, it is 45%. So there is a reduction in 55%. And this is OR, we have to give in OR 0.55. This is a 95% confidence interval, and this is p value. Okay. So from like 95% confidence interval and p value, from these things came, I will show in SPSS. So how to interpret Cox regression or hazards ratio finding? If we apply Cox regression or hazards ratio, then how to interpret it? So interpretation of finding, you can please be attentive for this. Risk of having lung cancer in smoker is 7 times compared to risk of having lung cancer in non-smokers. So it is finding of, we can say it is similar to odds ratio, but in Cox regression or hazards ratio, you have to add it at any given time point. So it is hazards ratio. When we add a time of event, so it is hazards ratio. So and we have to like write down HR means hazards ratio 7.0, 95% confidence interval, p value we have to give. In other terms, we can write down according to this also. It is also good. Risk of having bed sore in intervention group, this is a bed sore study, is 0.55 times compared to risk of having bed sore in control group at any given time of point up to 3 months, because we have only 3 months follow-up. So this is hazards ratio, and this is 95% confidence interval, and this is p value. Hazards ratio and odds ratio both are different things, because in hazards like odds ratio, no need to add time point, but in hazards ratio you have to include time point, and these values are just for examples. These are okay, just for examples. This is assumptions. Okay, it may be different from odds ratio. Okay, and usually it is different from odds ratio. And how can we interpret in third, we can say in third situation, or we can say this is the interpretation of finding. So risk of having bed sore in intervention group is 45% lesser compared to odds of having bed sore in control group at any given time point up to 3 months. So this is, we can interpret this finding according to this also. Okay. And risk of bed sore development in intervention group is 45% lesser compared to control group at any time point till 3-month follow-up. So we can interpret according to this also. So all are like correct form of how to interpret. So whatever finding, whatever interpretation you like, you can interpret your findings, okay, of odds ratio and hazards ratio. So what you see in these two studies or results, these are only crude results, not refined results. Why? Study 1, because there are many other factor variable conditions which are called confounding factor are also responsible for lung cancer, like gender, age, family history, occupation, any other cancer, etc. But we did not consider or analyze and adjust for those before giving final results. Okay. And study 2, because there are many other factor variable condition which are called confounding factor are also responsible for bad sore development, like gender, age, BMI, disease severity, poor hygiene, socioeconomic status, any other condition, etc. But we did not consider and adjust for those before giving final results. So these results are only crude results, not filtered result or adjusted result for confounding variables. So for this, we have to calculate and we have to do adjustment for OR, odds ratio and hazards ratio. If any other factor, condition or independent variable is significantly associated with outcome, outcome is bed sore development at 3 months or lung cancer development. In univariate analysis, like in t-test or chi-square test, so we have to, before going to hazards ratio or odds ratio, we have to first perform univariate analysis. Hazards ratio and odds ratio are multivariate analysis. So before going to this, we have to apply univariate analysis, that is a t-test and chi-square test. Always we have to apply univariate analysis for our outcome on. Okay, then we have to adjust these factor, condition, variable before announcing final interpretation. Means if these conditions, factor, independent variable are coming significant in our univariate analysis, like in t-test or chi-square test, then we have to adjust these factor, or these are called confounding variable, in using multivariate analysis, that is a binary logistic regression or Cox proportional hazard model. Then we have to give final interpretation. So it is called adjusted odds ratio, AOR, or adjusted hazards ratio, AHR. These are automatically done in binary logistic regression as well as in Cox regression model in SPSS. So there is no need to worry. These are automatically done. So let's have fun. Okay. So now we have we will have SPSS file. We have to open. So this is my SPSS file. I think I have sent you in group participants group, and I hope that you have downloaded and opened in your laptop. So still you didn't open it, please open it. Then this is bed sore study. So we there is an intervention group and there is a control group. In intervention group, we have given mobile application for the training of the caregivers to prevent bed sore in their patients. Okay, in stroke patients. In control group, we have just given usual care. Okay, so intervention group is mobile app group and control group is a usual care standard group. So there are long, I can say there is a long data sheet, but for this demonstration, I captured only these variable. For example, history of previous stroke or TIA, that is a transient ischemic attack. Okay, it is a mini stroke in the patients. So I captured on only this variable, and in caregivers, I captured only age of the caregivers, and I captured only Kupuswamy socio-economic status okay scale on this. Okay, why? Because these variable only these variable came significant in univariate analysis. So to adjust these variables in regression model, I have to adjust these variables, then I can give final results. Otherwise, these were not final results because these are confounding. And how these are confounding, okay, we will see this. So I have to see whether this history of previous stroke or TIA is confounding variable or not. So I have to compare with this group. This is my group. Okay, this is independent variable. This is a dependent variable. So how I can do it? So I know that this is using t-test or chi-square. Okay, because the control this group is only like two groups. Here two groups. Okay, the only two categories. So this is a control and intervention. If you have two groups, okay, and then this history of previous stroke or TI is also 2, 0 and 1. 0 means absent, 1 means present. History of previous stroke and TIA. So there is category and independent variable. There is a dependent variable is also category. So this is C, and then we have to remember third C also. That is a chi-square test. So how to do this? Okay. Next, I will show you how to do again. And next, you can see here, this is a Kupuswamy scale. This is the age of caregiver. Okay, first, please come here. Age of caregiver. You can see here, age of caregiver. So age of caregiver is a quantitative variable. You can see here, quantitative variable. And where how many groups we have? We have two groups, intervention and control. So to compare this age, mean age of caregiver between intervention and control group, we have to use t-test. If these data age of caregiver is normally distributed, otherwise we have to go for man-Whitney. Suppose this is a normally distributed, okay? So I have to use independent t-test, okay? Next, third is Kupuswamy scale. This is lower, upper, lower, middle, lower, middle, upper, middle, and upper class. And I have given this code. You can see here. So you can see here, like when you click this Kupuswamy scale code and click right click in and ascending, short ascending, you will click on short ascending. Then you can find out when we arrange in ascending order this Kupuswamy socioeconomic code. Then you can see here 111, 222, 333, 444, 555. Then you can see here 1 is a upper class, 2 is a middle class, upper middle, third is a lower middle, fourth is upper lower, you can see here, and fifth is a lower. So please remember this. These three confounding variable we got in univariate analysis. Okay, I'll give you demo again. So for chi-square test, what I have to do? I have to go in analyze, descriptive statistics, and then cross step. Okay, then click this. Then what I have to do? I have to bring this group in column. So please bring this group in column. Then I have to bring this history of previous stroke or TIA in row. So please bring this. And then Kupuswamy socioeconomic status code, please bring here. Okay, in row. Then we have to click exact. So please click exact, continue. Then click statistics. In statistics, click continue. The chi-square, please click chi-square, tick chi-square. Then continue. In sales, you have to click in percentage column. I always prefer column. Okay. Then click continue. Okay. Then click OK. So this is a result. You can find out this. Then this is a previous history of previous stroke or TIA versus group. And because we don't have much time, so I have to see only p-value. So how can I see? This is a chi-square test p-value. First you have to see this A. This is 0 cells have expected count less than 5. Okay, 0 cells. So for this condition, we have to take Pearson chi-square p value. This is Pearson chi-square p value is asymptotic significance two-sided. So it's coming significant. It is 0 point less than 0.05. It is 0.013. So in univariate analysis, this history of previous stroke or TIA came significant. So it is a confounding factor. We have to adjust this. Now Kupuswamy scale, please see. Oh, very good. Kupuswamy scale. Versus group. So this is 1, 2, 3, 4, 5. So one is what is one? One is upper class and five is a lower class. Okay, if you remember. So we have to see this p-value chi-square test. So you have to see this is 2 cells have expected count less than 5. So here you got 2 cells. So if you got 0 cells here, then you have to take Pearson chi-square p-value asymptotic significance two-sided. But here you got 2 cells or 1 cell, 2 cell, 3 cell, 4 cell, 5 cell, whatever cell you will get here, then you have to take a p-value of Fisher exact test and exact significant two-sided. Please take always two-sided. It is 0.011. So it is also coming significant. So socioeconomic status is also confounding factor. Now age of caregiver. So what I have to do for age of caregivers? I have to use, there are two groups. This is age of caregiver is a quantitative variable and it is normally distributed. Suppose I have done normalcy analysis and it came normal distributed. Okay, Shapiro-Wilk p-value is greater than 0.05. So it is normally distributed. So I have to use independent t-test. So how can I use? Click analyze, then compare means, then we have to do independent sample test. Okay, so please click this. Then what I have to do, I have to bring this age caregivers in test variable. So please bring this. Then I have to click this grouping variable, group in grouping variable. So please click this. Then define group. So I have to give, suppose I have to give coding 1 and then I have to give coding 2. Then click continue. Then click OK. So what I got the group sum command specify an unknown variable or a long string variable. The sub command must specify either a numeric variable or a short string variable. Text found group. Execution of this command stop. So what is wrong here? So I have to see my data sheet first. So what, in grouping variable, you can see I did not give coding it. Okay, I did not give any coding to it. Okay, so first I have to give code this. So for code, what I have to do, I have to click transform here. Okay, then I have to give recode into different variable. Please use always recode into different variable. Please click here. Then which I want to give group. Okay, group. Please bring this group into input variable, output variable. Please click this arrow. Then output variable, I have to write down group underscore code. Then I have to click on change. So please click on change and this group code will come here. You can see here. So this is group converted into group code. Then I have to click on old and new values. So please click on this old and new values. And what is old value? Old value is a control. I think it's only control. You have to see same spelling you have to type here. It is a control. C capital and other are smalls. And I have to give value 1. So please click on 8. So it will come here old to new. Old is control, new is 1. Then intervention, only intervention here. Okay, so I capital, you have to see I capital intervention. Then I have to give value 2. Then click in new value 2. Then click add. Okay, then click continue. Then click OK. So you can see here this group code will come at the end of this yeah, data sheet. You can see here. Okay, none is missing. Oh, it's okay. Then this is 1 and 2. So I have to decode it. So for decode it, what I have to do? I have to double click it. Then this is group code. You can see here. This is group code. Okay. And in value in front of group code, below this value, I have to click this here. Then I have to give value 1. Then tab, this cursor will shift from value to label. Then I have to give control. Okay, 8, please 8. Now value 2, I have to tab and intervention. Okay, intervention. Then click add and okay. In 30 like version, you know that what is if you remember that there is some difference in values. So you have to like click green plus something like that, and you have to in value you have to add 1, and label you have to type control or intervention, then click okay. Okay, so it will come here. Then now I have to see independent t-test. Okay, so click analyze, compare mean, independent t-test, and then this group code will be here. So I have to remove this grouping variable. So what I have to do, I have to click this, I have to click this arrow, then I have to click this group code, then I have to bring this group code in grouping variable. So I have to click this arrow, then define groups. It is 1 tab 2, 1 tab 2. Okay, then click continue. What codes you have given, you have to type only these code, then click OK. So this is okay. So it is coming. You can see here, this is mean and SD of age of the caregiver in control and intervention group, 80 participant. You can see this is the mean and standard deviation. Then you can see this is equal. This is a Leven's test for equality of variance. You can see here, and this p value, this is a p value. You can see here f value is this 5.496. This is p value 0.020. You can see here it is less than 0.05. Then you have to take equal variance, not assumed p value, and this is SIG2 tailed is a p value of independent t-test. You have to take this p value 0.003. Why this? Why not 0.002? Because this 11th test of equality of variance is p value is less than 0.05. So it is not equally variance assumed. It is equally variance not assumed p value you have to take. So it is also coming highly significant. These three are, you can see, confounding variable. I got these three variable as a confounding variable in my study. So now we will go for binary logistic regression. I will take only 5 minutes for binary and 5 minutes for Cox regression. Okay, so 7:10 we will finish it. So click analyze. Then for binary logistic regression, we have to click regression. And this is for multiple or simple linear regression. For binary regression, we have to click binary logistic. Analyze regression binary logistic. Okay. Then click here. Then this window will open. So what we have to do? We have to, in dependent variable, we have to, this is bed sore development at 3 months, 0 and 1. You can see in your data sheet 0 and 1. 1 yani bed sore developed, 0 yani not developed. So I have to click this and bring this outcome variable in dependent variable. So please click this arrow. So it came here. It must be always binary, 0 and 1 format. 0 and 1. 1 means the outcome of interest. Okay. In covariate, I have to bring all confounding variable and my group code. Okay. So please, you have to bring this first group code. So please bring this group code here. Group, okay, intervention and control. Then history of previous stroke. Then age of caregivers. Then Kupuswamy scale socioeconomic code. You have to bring all these variables, because I want to see, I want to adjust these variables, and I want to see in group code whether bed sore is like my intervention group is like can decrease the incidence of bed sore. Okay, that is F group. Then you have to click this categorical, because we know group code is categorical variable, history of previous stroke is categorical variable, and Kuppuswamy socio-economic status is also categorical variable. But age of the caregiver is not categorical variable right now. Okay, so we have to click categorical variable here. Then bring all these categorical variable in categorical covariance here. So click one by one and bring here. You can see here, then we can see here. Now main thing you have to remember here. Age of the caregiver is not categorical variable. Okay, so please bring age of the caregiver in this covariate. But in categorical variable, what other categorical variable you have to bring here? Then you have to select. This is reference category, last and first. Please remember this. What code we have given? Okay, so if we given 1 and 2 code for group code, okay, group in group, 1 is control, 2 is intervention. Okay, so we have, and what we want to see, we want to see intervention effect on bed sore, and control is 1. So please always give reference category as your control, and for control we have given 1. So here 1 and 2, there are 2 categories. So 1 is first, 2 is last. So we have to give reference category as 1. 1 is first. So I have to click this first, then I have to click on change. When you click on change, you can see there is some difference. Okay, here, you can see here, click change. So this first will come here. Group code indicator first. So what do you mean by first? This means it's in this case, first group is your reference category. And what is your first group? That is a control group. Okay. Now, history of previous stroke or TIA, we have coded 0 and 1. So what is 0? 0 means no history of previous stroke, and 1 is history of previous stroke or TIA. So in this case, 0 is first, 1 is last. So always take reference category no as a reference category. Okay, always take no as a reference category. Okay, so what I have to do, I have to select it already first, then I have to click change here. Then this first will come here. Now Kuppuswamy scale. So here we have 5 category, 1, 2, 3, 4, 5. So 1 is first category, 5 is last category. So what is 5? 5 is lower category. If you remember, 1 is upper category. So I can make 1 as a reference category or 5 as a reference category. Whatever you want to make, you can make. So I will make here lower is a reference category here. So what I have to click here, because lower socioeconomic status, I have given 5 code. So 5 is my last code. So this is for reference category. I have to click last here. Then I have to click change here, and this last will come here. Okay, one. Okay, it is already last. If you not select this, it is by default it will come. It is last. If you not click here something like that, then it is default is last category. Okay, it will take last category as a reference category. To make first category as a reference category, we have to select first and then we have to change. For last category as a reference category, we need not to like change anything. So it is default last category. Then click continue. It is for Cox regression as well as binary logistic regression. So click continue. Then you have to click option button here. So you have to click option, then you have to click this CI for exponent B 95% confidence interval. So what is exponent B? Exponent B is odds ratio, and CI means 95% confidence interval of this odds ratio. No need to do anything in this. Okay, then click continue. Okay, then you have to click OK. Then you will get this finding. There are 8 missing cases. 8 means loss to follow up. Okay, so there are 8. There are total 160. 80 in control group, 80 in intervention group. There are 8 missing cases. So we are analyzed only 152. So this is a original value is 0 and 1 and internal value is 0 and 1. What do you mean by 0 and 1? 0 means control group, 1 means 0 means here dependent variable coding hai. So 0 means no bed sore, 1 is bed sore because bed sore is our dependent variable. So 0 is no bed sore, 1 is bed sore. Okay, so this is, there is no need to do anything. We can see here categorical variable coding. Okay, so in Kupuswamy scale, you, if you remember, we have made reference category last category as a reference category. So you can see here last is 5. So you can see here in front of this 5 there is 0 0 0 0. So 4 are 0. It means it is a reference category. So in Kupuswamy socioeconomic status 4, you can see here, here you can see here 4 and it is given as 1. So if you see here in Kupuswamy scale there is a 4, it means it is a 4 here. Then you can see here in third, at the place of third, you can see here 1 and 1. It means here reference category is last category. But you can see here history of previous stroke or TIA. You can see here we made in first category as last category. So you can see 0 and 1 we have given coding, okay, to previous history of stroke and TIA. So you can see 0 means previous first category and here 0 0 0, it means it is a reference category. And 1 1 is we want to analyze this, we want to effect of this. Okay, in control group also we have made 1 and 2. It is coding 1 and 2. So 1 is our 0 is our 0 1 and 2. So what we have selected? We have selected first category as a reference category. So what is first category? That is a control, and intervention is last category. So here 0 came here because we have selected as a reference category this. Okay, then what we have to see? We have to see this table. Okay, we have to see this table. This is odds ratio table. You can see here. So this is a very very famous table to interpret odds ratio. Then you can see here in group code, in front of group code, you can see this is exponent B. This is odds ratio. And this is a lower bound of odds ratio. And this is a upper bound of odds ratio. You can see here. Okay. And this is P value. P value is less than 0.05. It means it is coming significant. And all other, you can see here, all other history of previous stroke, Kupuswamy, age of the caregiver, the P value are coming not significant. You can see here. So so group code or group, that is the intervention and control and outcome is our development of bed sore. So this is a filtered result. This is adjusted odds ratio. Okay, this is 95% confidence interval of the adjusted odds ratio. So we can say here in control, in intervention group, there is odds of development of bed sore at 3 months is 0.257 times compared to control group. Okay, with odds ratio of adjusted odds of 0.257, and this is 95% confidence interval lower to upper, and this is P value 0.016. We have to give our result, interpret our result according to this. Okay, so after adjustment it is called adjusted odds ratio. Now I will take only 2 more minutes to do Cox proportional hazards. It's already late. So what I have to do for this Cox proportional hazards? Click analyze. Then what I have to do? I have to go for survival. Okay, I have to go for analyze and survival. Then Cox regression I have to do. I have to go Cox regression. Survival, time life table, Kaplan-Meier, then Cox regression. So I have to click Cox regression here. Then it will come here. So in time, if I take bed sore. So what is time? Time is a development of bed sore. This is a variable you can see here. Time in days of bed sore development. So I have to put this in time. Okay. So click here in time. Then status. Status means what is your outcome? That is bed sore development. So I have to click bed sore here, and then I bring bed sore from here to in this status. And what is I have to define this event. So for bed sore I have given 1, and non bed sore I have given 0. So what is my event of interest? Bed sore development. So I have to click this. Then I have to click in single value 1, because I have given coded like bed sore as 1. So and click continue. Then in covariate, all the things which I like brought or took for binary logistic regression. So first of all, group code. Number 2, history of previous stroke, age of the caregivers, and then Kupuswami scale. Then again, categorical variable, I have to click categorical variable. I know that what are the categorical variable. Age is not categorical variable, others are categorical variable. So please select these and bring all these here. Then again, I have to change last and first category. Okay. So group code I have to bring as first category as reference. Control must be reference category. Okay. So for control, I have given 1 code, that is a first, and 2 code for intervention, that is a last. In 1 and 2, what is first and what is last? So I have to change. So click change here. For history of previous stroke and TIA, I have to again click change, because I 0, there is no history, and yes, there is a history. So always give no as a reference category, and 1 is yes as a like we have to calculate for this. Okay. Then Kupuswami scale, again I have to leave it, because I know that I have chosen 5, that is a lower class as a reference category. So no need to do anything. Then click continue. Then what I have to do, I have to click this option button. Then I have to click this CI for exponent B here. So it is and right now it is exponent B is a hazards ratio. In logistic regression, it is a odds ratio. Okay. Then click continue. Then plot, you can see here, these are the plots. You can see here, you can click survival, hazards, 1 minus survival. Okay, you can click here. No need to do log minus log. There is no need of this. Then what you have to click for separate line for, because we want the effect of intervention. So an intervention, where is intervention? In group code here. So I have to click group code. Then I have to bring this group code here. Okay. Then click continue. Okay. Then click OK. Then you will get a similar results table. Okay, it is going on. It may take some time. You can see here. It is taking some time. Okay, it may take some time. No problem. So okay, I think it is coming, but it will take time. I think generally it should not take much time for this. So no issue. I can click again. Cox regression, what I have done. Okay, it came, I think. So this it came. Okay. So it is event is 24, censored means 128. So who did not develop event, that is censored. As I told you, in Cox regression, there is a censored. And event means bed sore within 3 months developed only 24. Okay, out of 152, because 8 are lost to follow, lost to, because we don't have any missing values for this. Okay. So here we can see again, this is most popular table. You can see here variable in the equation, variable in the equation. So we can see here, this is group code, and this is for other history of previous stroke, caregivers, and Kupuswami. We can see for group code, because our outcome of interest or main thing is group intervention and control. Okay, so we can see here, this is exponent B. This time it is not odds ratio, it is a hazards ratio. This is 95% confidence interval odds ratio, hazards ratio, sorry. And this is P value. It is still coming significant, 0.012. After adjustment, it is coming significant. After adjustment of these history of previous illness, age of caregivers, and Kupuswamy scale. Why we adjusted these things? Because these are confounding variable. These were came significant in a univariate analysis. These were come significant in univariate analysis. So we have to adjust for this. So what we have to, we can say here, there is a the risk of development of bed sore in intervention group is 0.287, okay, times laser compared to control group at any given time point up to 3 months of follow-up. We have to add at any given time point till 3 months of follow-up. We have to add in a hazards ratio when we interpret. But in odds ratio, no need to interpret at any given time point, at any time point. Okay, and this is hazards ratio. This is 95% confidence interval of hazards ratio, and this is a P value because it is significant. So we have to write or interpret these findings after controlling these confounding variable. And you can see here, this is you can see here, this is a cumulative survival curve. You can see this is a survival curve. So here red line is for intervention and this blue line is for control group. So there you can see here, red line is compared to, it is development of the bed sore. So you can see here 100% are free here from bed sore, and in at 3 months you can see in intervention group only 90% around developed bed sore, but in control group around 78% developed bed sore. Okay, so in intervention group this is a difference you can see here. So this is a survival curve and this is a hazards curve. Okay, 1 minus survival curve you can see here, and this is hazard function curve you can see here. In this is a hazard function. Tomorrow we can have some discussion on these curve also. Hazard function curve, 1 minus survival, 1 minus survival or hazards are similar curve you can see here, and this is a survival curve you can. Okay, so this is all about odds ratio, hazards ratio. Okay, how to do independent t-test, chi-square, how to give coding to. So I think there are a lot of repetition today. So it is, I think, give lot of, you can see here, exercise for you. You can remind all these things. So thank you.
Thank you, sir.
Okay, so if you have
The
question.
first question we received from Rajeshwari Bingi.
Ji.
It is while using ANOVA statistic to check the effectiveness of an intervention, if the significance come at any one time point like baseline and first follow-up, or any combination baseline, 3 months, etc., can we interpret intervention is effective?
No, ANOVA, we didn't use any ANOVA in this. I think we didn't use today any ANOVA test. We use only chi-square and t-test. Okay, then binary logistic regression and Cox hazards ratio, something Cox proportional model. So I'm not getting her question. So can you repeat it?
Sir, while using ANOVA statistic to check the effectiveness of an intervention, if the significance comes at any one time point, like baseline and first follow-up, or
Okay.
any combination baseline, 3 months, etc., can we interpret intervention is effective?
Yes, we can interpret it that intervention is effective. But if you have confounding variable, like other things are coming significant. For example, age, for example, BMI, for example, knowledge level, practice level, any other things. So for this, you can interpret these results, but these are crude results. These are not filtered results. So for your thesis, mainly for like post graduation level and doctorate level, you have to give filtered result or adjusted results. So for these confounding variable, then for this you have to apply binary logistic regression, multinomial logistic regression, multiple linear regression, and then hazards ratio, these things. Okay.
Yeah. Another question is from Rupali Verma. It is, sir, it is lengthy process. If we forget any steps, then how can we assure that our result is correct?
No, you will get because it is lengthy, but you have to get these recordings so you can practice. When you practice, then you will get it. So you have
Next
to do,
question is,
you have to do practice. After
next question
practice,
is,
you will see that okay, it's very easy. It's not lengthy. Okay.
next question is, sir, what is the significance of changing the reference category to first and last?
Okay, first and last. Okay, so it is like a very meaningful question, that first and last. So because want like was think what think want think I want to see. Okay, for example, I want to see the effect of intervention. It is my main objective, main aim of the study. Effect of intervention. Okay, so if I and what effect of intervention, so if I make my intervention as reference category, so these result will give for control group, not for intervention. Okay, so there is some confusion in this. You can interpret according to this, and then what you have to interpret, you have to interpret in odds of having bed sore in control group is this much, because there is a you can see here there is a like what you odds ratio and 95% confidence interval, there is changing. You can like get change. Okay, I'll give short demo for this. It is very good question. So okay, for example, for this logistic regression, then I will not category, I will make this category as last. Okay, no problem. Also I will make category as a last. Then what will happen, you can see. Okay, continue, then click okay. Then what you will find out, you will find out before you see in that case, this is binary logistic regression here. Okay, I think this is binary logistic regression. You see here, this is a result of the binary logistic regression here. This is for intervention group. You can see here 0.016, and this is odds ratio 0.257, 0.085, 0.778. But when I change my reference category from control to intervention, so you can see here, this is coming like this: 3.3, 3.889, 1.268, 86, 11.760 automatically changed. P value is same. Okay, but this exponent value is changed. So this is for control. Odds ratio of development of bed sore in control group is 3.8 times more compared to intervention group. So this is interpretation will change if you change reference category. So, but our main motto is to like interpret our intervention group. So we have to make a control group as a reference category. So there are some rules to which like which category we should take reference or not. As I told you, if you have yes and no, diabetes yes and no category, so please take no as a reference category, because we want to see effect of diabetes on any disease, any other CAD. So for this, we have to make no diabetes as reference, then I can see effect of diabetes on CAD. Otherwise, if I make diabetes as a reference category, so what I will see? I will see no diabetes, effect of no diabetes on CAD. So I think this is some awkward some things, because everybody want effect of diabetes, effect of like TB, effect of BMI, effect of this, effect of age. And none want no effect of no like effect of no TB, effect of no hypertension, effect of no diabetes. So this is some awkward. Okay, so make always no as a reference category, not yes. And in your intervention group is don't make intervention group as a reference category. Always make control as a reference category, so that you can interpret result for your intervention group. Okay, thank you.
Thank you, sir. Next question is, what univariate analysis you do to find confounding variables and how?
Univariate analysis, I have I think I have given demo t-test or chi-square. And I think I have explained 3-4 times it. Okay.
Yes, sir. So next question is, sir, in an experimental study of two groups, if we have more than one dependent variable that are quantitative and one or more than one confounding variable, can we apply logistic regression?
No. If our like quantitative, then we have to go for multiple linear regression. If our dependent variable is quantitative, then we have to go for multiple linear regression. Okay.
Another question is, sir, should we consider only the confounding variables that are significant in the univariate analysis for the regression?
Okay, it is very good question. Sometimes because like we are health researcher, some variable came significant in univariate analysis, but there are some variable they are like interested as a point of view of health researcher clinicians, because I want to nullify effect of this, for example age, creatinine level. Sometimes age and creatinine level and any other most important variable did not come significant in univariate analysis, although you can take in multivariate analysis. Okay. According to your experience, which variable you want to take or which variable you don't want to take. But in the rules, if your univariate p value less than 0.2, then you can take this variable as a confounding variable, or you can adjust for that variable. I took in this demonstration only those variable which came significant, p value less than 0.05, but you can take p value less than 0.2 up to 0.2 or less. You can take these variable for like your multivariate analysis, binary, as well as your multiple linear, as well as your hazards ratio calculation.
Thank you, sir. Next question is, sir, will we discuss about incidence rate ratio and relative risk and absolute risk?
Okay, in you can see in rare condition, when the disease are rare, in this condition, relative risk and odds ratio are same. So relative risk interpretation is something else. Okay, so sometimes interpretation of a relative risk odds ratio is more powerful or robust compared to relative risk. So nowadays in health research, calculation of relative risk and risk ratio, I think ignoring, and odds ratio are like we can say we are giving more focus on odds ratio, because it gives clear cut pictures of phenomena, any phenomena. So we use this, not risk ratio and 95% confidence interval of the risk ratio. Okay,
Thank you,
next.
sir. That's it, sir. No more question in chat.
Okay, okay, okay. Thank you.
Thank you, sir.